In this video, we're going to be discussing the concept of solubility, which is just a way of saying how much of a solute will dissolve in solution. There will be some vocab in this, so be prepared to write some of that stuff down. We're also going to be working with a couple of graphs in here, but you will need something to write on, you will need something to write with, and when you have all that ready, let's go. So to start off with a couple of definitions, right? So solubility, the definition for that is how much of a substance, or solute in this case, measured in grams, will dissolve in a given amount of water. Typically, when we talk about solubility, we're talking about grams of solute per 100 grams of water. Right? So that's the typical unit that you're going to see for this. Now, we have a couple of terms that relate to the solubility of a substance, and that is saturation. So we have three different levels of saturation. A solution that's unsaturated means that it has less solute than it can hold at that temperature. So if you add more, that extra will start to dissolve. Right? So unsaturated, not enough dissolved. Saturated has exactly the right amount dissolved, so as much as you can physically have. If you add extra solute to a saturated solution, it will just sink to the bottom and not do anything. And then we have what's called a supersaturated solution. In a supersaturated solution, you have more solute dissolved than what the solution is supposed to hold. Now, if you disturb a supersaturated solution in any way, it will precipitate. Precipitate means that it will crystallize, it will form a solid. Right, so what I have coming up on the next slide is an example of a supersaturated solution. So in this diagram, on the left, we have a supersaturated solution of calcium acetate. Above that is sitting a single molecule of calcium acetate, so one crystal held by the pair of tweezers. That gets dropped in, and you can see in the middle picture, as soon as that crystal gets dropped in, the solution begins crystallizing around it. And eventually, like 20 or so seconds later, the entire solution has recrystallized, and all of the excess solute is now a solid. Right, so this is how a supersaturated solution works. The way that you actually go about making a supersaturated solution is that you make a solution that's saturated, and then you cool it down very slowly without disturbing it at all. Don't touch it. Don't shake it. Don't think bad thoughts about it. If you do that, it will become supersaturated, and as long as it stays still, everything will remain dissolved. The moment you disturb it, either by adding what we call a seed crystal, which is what that crystal of calcium acetate was, or if you disturb it by shaking or stirring or doing anything else, it will recrystallize. Now the question is, how much of that calcium acetate did recrystallize? Because I can tell you right now that not all of it did, only some of it. And the way that we can figure that out is by using something called a solubility curve. Solubility curve is just a graph, right? So this measures how much solute 100 grams of water can hold at any given temperature. Right, so the diagram that we have here is a solubility curve for a bunch of different substances. Every point on those lines represents a saturated solution. Right, so for example, if we look at potassium dichromate K2Cr2O7, at 80 degrees, you can dissolve about 60 grams of potassium dichromate in a saturated solution. Now, if your solution is unsaturated, that means the amount dissolved is below that line, so you can add more up until you get to the line. If you have a supersaturated solution, that's above the line. And what will happen is if you disturb it, it will crystallize out until it gets to be saturated. So our potassium dichromate solution, for example, if I had 80 grams dissolved at 80 degrees and I disturbed it, then all of that excess getting me back down to around 60 will crystallize out. So we'll lose 20 grams of our solute recrystallizing to form a solid. Right, so what will wind up happening is as we cool down the substance without moving it, you notice it gets less and less and less soluble. So then when you disturb it, it goes straight down to the line where it happens to be. Right, so this is just being able to read a graph and answer some questions based on a graph. These won't be really hard to do as long as you can read it appropriately. Okay, so that's it for solubility. In the next video, we're going to be talking about some concentration stuff. So concentration is a mathematical measurement based on the amount of solution that you have, so different units of concentration. For that part, you will definitely need a calculator, so I will see you guys in class.